Hello there. Welcome back to the Intro to Programming with Rust course. This is the third video. We're going to be covering functions. We're going to be covering statements and expressions, or statements versus expressions, both of them. And we're going to be covering comments. So let's jump in. Functions are fun. Well, actually, before we jump in, I want to show you this. This is a pretty cool little site. It's called Are We Yet? You can just Google that. It's by Mozilla, the people who make Firefox web browser. And they have a bunch of statuses, like status pages on all kinds of different programs and abilities that different web things can do. And there's a few for Rust here. So Are We Audio Yet is a Rust one. This is one of my favorite ones. This Are We Game Yet? Let's find it. There it is. Are we game yet? It kind of just gives an update on Rust game development. Are we GUI yet? Graphic interface in Rust. Development environment. There's some really cool ones. What was the other one? Oh, web. So let's look at these. So audio. This shows you just kind of some stuff revolving around audio in Rust. Game. This shows some Rust games. This one's really cool. So these are all games that are built with Rust, and there's some cool games in there. What do we got? The ecosystem. So this shows all kinds of tools for building games in Rust, and Rust is really good for games because it's a fast language and it's compiled and it's systems level. So it's just like pretty much ideal for coding games. You can get some news here. Oh, no, sort of. But anyway, yeah, so Rust is good for games, but it's such a new language, there isn't much of a ecosystem there for it yet. But it's getting built up, and this site's really fun to follow just to see how things are going. Are we GUI yet? Graphical user interface kind of updates. IDE. So this is just showing which text editors and integrated development environments, which are also, more kind of fancier editors, which have abilities for Rust. That's pretty cool. Are we web yet? What you can do with Rocket is like a web framework. It's for basically building web servers or websites. I can't remember exactly. Something like that. But yeah, so web stuff. I don't know. Just cool like website to look at. So just wanted to show you guys that. All right, let's do some functions. So what if a function is basically a black box that does some kind of processing. It can take data in to process. So it can, that black box, you can feed it data and it'll process that data. And it can also spit data out. So just like, say this is a function right here, this black box, you can shoot data into it, it'll process it, and then it'll shoot the data out. Or you can just have it process something without giving it any data. But typically you're going to be feeding it something that it's going to process. Another way to look at a function is a variable that holds a program or that holds some code instead of just a value. You can see in our program right now we have this main function. Every program in Rust has to have the main function. That's basically the starting point. But yeah, so this main, that's the name of the function. That's like a variable basically that just holds all this code. So, and we can put functions in here, which we will, and we'll actually put our equations in a function just to make it more modular. You can use them in other places, or you can use it multiple times throughout your code. Functions are really good for making your code modular, usable, kind of like swappable. You can swap one function out for another function, and they're really cool. So the convention that Rust has for naming functions is just like variables. It's snake case. So when you're making your functions, that's what you want to do. So let's add a function to our program here. So the way you declare a function, it's not with the let keyword like with a variable. The way you declare a function is just with the fn. What do we want to name our function? let's just say calc discount. So you kind of want to name it like what it does. It calculates the discount, right? So calc discount, and functions have these parentheses after them. That's where you would feed it data if you're giving it data, and we will actually give ours that. And then it has these brackets, the curly brackets. Anything inside the curly brackets, that's the code, that's the program that runs. This is the black box right here. You don't need to know what it does, really. You just need to know what you feed it and what it's going to spit out. You need to know. Now, you do need to know what it does. You don't need to know how it does it. So you can code this, put all your code in here, and like 5 years later, come back, and as long as the language features that you're using aren't obsolete by then, you can come back and just say, oh, this calculates a discount. It takes this and this, and it should give me the discount price. And you put it in. You don't even need to know what the equation is, and you can still just use that function. So functions, so what we can do is once we have our function created, when we want to run it, we have to do what's called calling it. And we can just do that by putting it somewhere in our code. You can put it anywhere. Put it down there. We could put it up here. It doesn't even have to be, it can be before where it's created, anywhere. So let me undo all those. All right. So let's work on our calc discount function. Let's just copy and paste, or cut and paste this in here for now, and then we'll get things working. So how do we want to do this? So we need to, first of all, we're going to need to feed in the original price, or just the price, I guess, and the discount percent. So, and those are both going to be F64s. So this is how you tell it what you want to feed into it. This will make more sense as we go. It'll start kind of clearing up. So we'll use this O for our original price, and we'll use this D for our discount percent. So when we take our original price in, we don't want to just say price, we want to use our O now. So that, because that's kind of feeding through here as an O. So we got our O, our discount percent is going to be D. We can leave our 100 just like that. That's fine, because that's going to actually, that's a constant throughout the whole program. Price, we can just leave that price. But this is going to be the original price there, and then dollars off will be the dollars off, because that's not coming in anywhere. So and then we need to tell it what value to return. So this is what data it's going to spit out, and we'll just say return price. So that means whenever we call this somewhere, calc discount, and tell it what we want to put into it, whatever it, and we're going to give it a variable. Actually, we can just change price. We'll just make this mutable so it can be changed. So price, we're going to set it equal to whatever calc discount spits out, it's going to spit into this price variable. Now here's what we got to feed it. So into this original price, we're going to feed it just price, right? So price. And for the discount percent, we're just going to feed it discount percent. What it sees is it sees those values, and it assigns that one value to O and the discount percent to D, and then it uses those throughout the actual function. So don't worry about understanding that too deeply. As you work through them, through functions yourself, you're gonna start to grasp them, and it'll come to you pretty quick. So just kind of stick with me here. Let's see if let's see if this runs right now. Oh man, I saw a bunch of errors there. What do we got? So first assignment to price, make this binding mutable. Did I? Oh. Taken in price, but it's not. I think it should take care of that error. Sometimes it's fun to just go through error by error on the compiler. Let me clear this and start fresh. It's kind of like a game. It's like, let me chop this bug up, fight this bug, kill this bug, kill this bug. Here's where we started it. Expected F64 found array. Oh, we got to give it one of our array values. Let's give it, what, 50%? Does that work? So that's the 4. 0, 1, 2, 3, 4. Yeah, so that's one more bug gone. Let's see what else we got here. Oh my goodness, there's so many. No, wait, that's not right. Here's where we ran it. Cargo run. Calc discount. Expected F64 found something else. That's F64. Maybe if we explicitly declare that as F64. Let's try that. No. What's it doing? Price. Dollars off. Let's set these to F64 too. Oh, we got to tell it to return an F64. That's one part I forgot. There. So this is the value that it takes in, the data type of the values it takes in. This is the data type that it spits out. So now we told it to spit out F64. So that should work. We shouldn't even need this now. Let's try that. And we shouldn't need this either. There we go. Yay, 1995. And what's it saying? Warning variable does not need to be mutable. Oh, that doesn't need to be mutable because we're not changing it anywhere. All right. So we got our function in there now. So this function, we could actually assign that to that, and then we could use it again, and we could say like second price. And we could say calc discount. And we put our price in there. Let's say our price is $39.99. We just put it right there. And let's say our discount percent is, no, let's make a different price. Let's say our price is $1,000. And our discount percent is 25% off. And we can just feed it that, and it's going to give us our value. We'll just use this. Second price. This is where functions become really useful. What did I do? Oh. Just need that decimal, I think. No? Unexpected token. Print line. Oops. Semicolon. If you see unexpected token, a lot of times it's a semicolon. Cannot find value second price in this scope. Oops. Gotta give it a let. Geez, I'm coding bad, but that's just coding. Like, you just kind of put stuff in and watch it. I mean, if you could plan it out, if it's a bigger program, obviously you're going to be doing more planning, but all right. So this is now, it's just saying, price is never read. We don't really even need this here, but we could just print both of them. Let's do that. And we'll actually say like, first price is that, second price is that. And it should print both of those now. First price is $19.95, second price is $750. All right, so we're working. Our function is working. And you see how functions can be useful because you can use them multiple times with different values and stuff. So we don't have to like copy this equation multiple times. We just write the function again and feed it some different data. So it's pretty cool. Oh, I didn't want to delete both of those. So let's delete the second price one. We don't need that, right? Just to clean things up, we want our function going good here. All right, so that's function. It's really, that's all there is to it. I know that it's tricky at first, but just remember, and you'll always be able to just Google function syntax for Rust or whatever when you're making a function. And once you have one in your program, then you just kind of look at the syntax when you need to make another one and just follow that. Sometimes you don't even need to give a function data. You might just have, a function that doesn't take any data but just spits out data. Sometimes you might have a function that doesn't even spit out data either. But, in our case here, we do. So that's our function. So let's look at statements and expressions. So statements and expressions are the two parts that pretty much make up a Rust program. They're like the electrons they're like the neutrons and the protons of the Rust world, kind of, I guess. So statements are lines of code that perform an action. So a statement performs an action. It does not return a value. So a statement, it doesn't return, like calc discount, that returns a value, right? It returns the price. A statement does not do that. So they can't be assigned to a variable. So a statement, let's see, what do we have in here that can't be assigned to a variable? Return price. You can't assign that. You can't say like let mute Bob equal return price. It just won't work. So that would be a statement. It performs an action, right? It returns price through the function. And it can't be assigned to a variable. It doesn't return a value. It performs an action. So that's a statement. Statements always end with a semicolon. Whereas expressions, they also perform an action, but they do return a value. So this is an expression. This is an expression. This whole function here, this is an expression. And they actually don't need to end with a semicolon. If you add one, it's actually kind of makes it a statement. And the reason these are statements is because this is an expression, but this whole thing is actually a statement. And that's because it's not returning a value, right? Let price equal, that doesn't return a value. We can't say like let, I don't know, hello equal let price equal. That's weird, right? So that's a statement. That's saying let this equal this. Boom. Whereas this saying original price minus dollars off, it does something and then it returns a value. So that's an expression. Let's go line by line here. So function main, no semicolon at the end of it, right? This is the whole function. No semicolon. So it's a statement. We're just stating what the function is. Constant assigning to a variable, that's an expression. No, I'm sorry. This is an expression. This is a statement. Statements always have the semicolon at the end. This is a statement, right? Just assigning to a value. But this array is an expression. It returns a value. It is a return value in a way. This is a statement. This whole thing is an expression. There's no semicolon at the end of it. And it returns a value. This is an expression, but this whole line is a statement. This is an expression, but the whole line is a statement. This is a statement. This is a statement, but this part of it is an expression. Is this an expression? Giving this value to the string. An expression returns a value, right? So yeah, that's an expression. But this whole line, once again, actually print line, actually that kind of is it's a statement, but it's an expression if we don't put that at the end of it, the semicolon, and it should work here. Yep, it still works. Because it's actually an expression. It's returning a value. It returns the value right to the terminal, right? So, yeah, that's statements versus expressions. And then let's look at comments. Comments are simple. Usually you can use them. We're going to use one actually right here, just to say what our function does. So, calculates the discount, or no, calculates the price after applying discount, something like that. So that's a comment. The 2 forward slashes. The problem with this kind of comment is once you go to a new line, it stops work. It stops being a comment. So it's only these two. This kind of comment only works for one line. If you want to do a comment on multiple lines, then you use, it's like a little flag thingy, and then we can do comments like that until we end it with the asterisk and then the forward slash. So forward slash asterisk begins it, asterisk forward slash ends it. Just undo those. Don't need that. Okay. We can just put, maybe we want to put at the very top comments like deal discount calculator by Joe Crite, November, what is today? I don't know, 2019. Ta-da. And there's some cool things I've seen people do with comments. This was a cool one I saw the other day just in some code I was working on actually. You line up the asterisks. And then you just, yeah, I don't know, I thought that looked cool. So, but yeah, so those are comments. And then I think in Rust, can we do, no, that's not a comment in Rust. Oh, no, the other thing with comments in Rust is you can do documentation comments, which is 3 lines. And if Rust has cargo. Let's see how we run our program with cargo. It actually has a way of creating built-in documentation with comments, but you have to use these document comments. So like we can say like section 1, I don't know, takes function to calculate calc discount. So then that would go into our documentation. So that's comments, pretty simple. So we covered functions, we looked at statements, we looked at expressions, and we covered comments. The next video we're going to look at, what are we going to look at? Let me see here. Oh, we're gonna actually capture input from the user from the console. So instead of just putting our discount percent here and our original price here, we're going to say, what do you want? What is the, print something to the console here that says, what is your discount percent? And then the user puts in, 50% or whatever. And then what is the original price? And the user puts in the original price. And then it calculates it. And there's some things that go along with that. So, but that'll be fun. We'll get user input. That's a little bit challenging in Rust compared to some other languages, at least with the terminal. Just because I think just more because Rust, it does have it is kind of a stricter language as far as just what it requires, just because it does aim to be a secure and fast, the securest and the fastest language, basically. So there's a little bit of a trade-off for that, but yeah, we'll get it working. It'll be fun. So thanks for watching and stick with us.